So why, let's see, wrong class, guy. There we go. Close that and that. Okay, so we're recording now too. And after lecture, I will be posting the lecture videos on a playlist. It happens really quickly these days. The processing is pretty effective. If you look on Canvas, there's this link to lecture playlist on YouTube. So you can click on that link, and this is where you'll see the lecture videos you can watch, pick up later. So a lot of times, you know, if something takes place during class, maybe I show you how to do something, you might forget. Well, this way you can kind of go back and just check the video out. That makes it really nice. Really helps people kind of get these things. So, or if you miss a class, you can pick it up also later. So yeah, if you miss a class, you don't even have to ask me what we covered. You can just pull up the video and watch the lecture, you know, at your own leisure. So yeah, so welcome. This is CSIS 10B, and I guess everyone here has taken CSIS 10A before, right? So you've all had the Java 1 class. This is the Java 2 class. We also have a CSIS 10C, which is a C++ intermediate class. Some people have taken that already before they take 10B, but you can do it afterwards as well. It's generally good to have a understanding of C++ and Java out in the world. There's just a lot of opportunities for working in both languages. And by the time you finish all three of those, you'll have a really good, solid grounding and really good confidence too in working in these languages. So this is the Canvas site, and we should start with the syllabus. So let's pull that up. And we are covering the applications of software engineering techniques in the design of large programs. And so we'll be what's interesting and challenging about this class is in 10A you wrote programs that were pretty much more or less in one file. Maybe you had some small classes adding to things to kind of show how object-oriented programming works. In this class, we develop a lot more extensive software to basically manage larger quantities of data. And we specifically look at ways of structuring our code so that the data is represented in a way that we can get at it efficiently. And that allows us to explore these things called data structures, such as vectors, linked lists, stacks, queues, trees, maps, hash tables. If we're fast, or if we get there, graphs, or people might explore that independently. It's not really, there's not really enough time to kind of cover graphs, but it is available in the textbook, and there's some materials available for you. And also sorting, searching, and then you get to apply this in a significant project. And there's a lot of cool projects you can do to kind of apply these concepts. These are really useful subject to kind of master. Once you get through this class, you kind of have a pretty good understanding how software development works, and you have a lot of tools to kind of make coding a lot easier for you. So that is the basic idea, and kind of the objectives kind of cover a lot of those things. As far as the activities that we're going to do in the class, there are these weekly online assessments. I'll explore those on Wednesday. Weekly labs worth 5%, and then you have 4 extended assignments worth a total of 10%, 5 quizzes, a couple tests, and a final project and a final exam. final project, again, where you get to apply these things in a project of your own choosing. And that's basically it, the typical breakdown for points. And then here is the tentative schedule. We'll be spending this week doing review activities and then going into basically the class is kind of divided into thirds as you look at over the first third of the class kind of focuses while we're sort of reviewing the language. We are also exploring what these data structures can do for us. So we'll be using lists, stacks, and queues in a way that will explain, why they're valuable. And then in the second third of the class, we actually make these data structures. So we create them from scratch so that we really understand how they work from the inside out. And this gives you the ability to make your own data structures later that might have special purposes and not be something that you can just get off the shelf, but something that you could actually tailor to your own particular needs. And we cover some other things along the way, sorting and searching. And then in the third section after test 2, we cover more advanced topics, iterators, dictionaries, hashing, and advanced topics, trees, organizing data like that. A lot of these topics are visited again once you transfer to university in a, this is sort of an introduction to data structures, but you'll actually get a full-blown data structures class on your way to your computer science degree, which will explore a lot of these things again, but in greater depth and more complexity. So very useful class, very great subject, and great skills to kind of master. As far as some of the various course policies, all of the announcements on Canvas will be sent to your MPC student email. If you haven't configured that yet, there's a link here you can click on to do that once you get in the class. I guess, yeah, you're all cool logging in, good. And oh, this should say CSIS 10B. I gotta stop copying and pasting. But basically, I've got a lot of students in a lot of different classes. So if you have a question like, when's my homework due or whatever, I'd like you to tell me what class you're in first in the subject line so I can orient that properly. Before I get to know everybody, I always get a few emails where I'm like, where is this person coming from? It is up to students to know when they should disenroll from the course. If you forget to do that and you just disappear, you may end up getting like an F in the class. If you make it in the class past the last drop date, which is like the first week of May, you'll end up being stuck with whatever grade you get. So it's your responsibility to maintain an awareness of where we are in the semester and whether you want to be in the class at the end or not. You can drop if it's not going well. It's a good idea to drop before the drop date, and your transcript will only get like a W on it, which doesn't affect your grade point average. And you can take the class again. Under certain circumstances, you can petition for an incomplete grade, but the registrar only awards them. They will. It's not even up to me, but they will often just refuse if you haven't completed 75% of the course and the emergency hasn't arisen in the last month of the semester. So you should be really aware of that, so that you don't, if you're relying on getting an incomplete because you didn't have time to get to the class earlier. You may get burned if it's not doesn't follow these particular criteria. If you have any special needs you'd like to kind of run by me, you can email me or just talk to me during my office hours. And if you need extended test time, the Access Resource Center will allow you to do that, and you can kind of see them or check them out on the web over there. Put this link here. And then finally, academic honesty. Be aware of your that basically the work that you turn in represents your own labor and not somebody else's. So that's a big deal. That happens a lot. Still surprised when I see that in class, but sometimes people will just turn in someone else's work. And it's in a lot of cases, these things kind of will show up maybe like on the final project or maybe on a test or something. Just be aware of that that's not allowed, and you have to kind of use your own head. It is great for people to work together on projects and labs, but I'd really like you to inform me when you're doing that and who the person is that you're working with, so that there's no confusion about that later. Any questions about the class I went over? Uh-huh. Well, when you turn in your work, at the very top, when you write your comments, you can put both of your names on it. Mm-hmm. Yeah. That would alleviate any confusion. Labs, do it if you're working with, put your lab partner's name on there. Anything that you turn in, that you're working with somebody else on. The assessments, everyone kind of has to type in their own answer for that. Yeah. I mean, you can work with somebody. You don't have to express that for the assessment. The assessment is a drill engine where people just kind of practice this basic syntax. Yeah, I'm not worried about that, but I am more worried about things like homework. Homework is pretty substantial, and you do this outside of class. And yeah, make sure it's your own work so that you don't turn in somebody else's. Yeah, it's easy to grab someone else and just say, "Can you email me? I can't figure this work. Can you tell me? Send me your homework too, because I can't figure it out." And I'll just look at it as a reference, and I will, I'll do my own work still. People will say that sometimes. Then they go ahead and turn in the work that you just sent them verbatim. Yeah, sometimes I've seen all kinds of crazy things, but sometimes I've seen work that yeah, there's some really funny examples where like somebody turned in, this is a different class, I think it was a MATLAB class, but they turned in like somebody else's work, and it had the other person's name on it, but not their name on it. So, they didn't do it at all. So if you work on it, put your name on it, but if you have a partner, put their partner's name on it as well. Right. And tests, obviously. don't collaborate on tests. You're not allowed to. Right? That's just for you. Yeah. Tests, you shouldn't put your partner's name on it. It should just be your name. I'm totally fine with collaboration. Yeah. Just put, if you collaborate with somebody, put their name on. Yeah. Yeah. It's an awkward thing, and I think a lot of well-meaning people, are afraid that they're going to get accused wrongfully or something. But it's more like, it really stands out, I think, when, well, like some things will happen, like, for instance, like for a final project, people have actually just downloaded some random thing from the internet and turned that in. And, that you might think you could get away with it, but typically, like, it's people that are often very confused. They don't really understand a lot, and they sort of think, well, I have something that works, so why can't I get full credit? But the point is, they didn't write it. And when it comes from somewhere outside the class, the kinds of techniques that people are using off on the internet often have very little to do with what we went over in class. So I'll be reading these things like, where did they come up with this? And they're like, oh, yeah, obviously it was the internet. And then I can like search for some of those weird techniques that I did on the internet. I can find the exact same file that they found on the internet, you know. So that's one way to really get me steamed, right? So don't do that. You know, some people have, you know, have a difficulty of programming, and they, you know, they think, oh, I just need to find the answer. But really, you've got to be able to develop the answer yourself, ultimately, right? You know, when you turn something in, it should be something that you know that you can actually do and reproduce yourself, right? So, the textbook, it says it's recommended. I do recommend that people get the book, but I think they've upped the edition now. This is, I used to use the 3rd edition. I think that may be out of print now, so they might be giving the 4th edition out now. If you can find the 3rd edition, that's fine as well. The 2nd edition doesn't really work so well for this class because it has a different organization. So go with at least the 3rd edition. Any other questions? What's the schedule for the homeworks? Well, the labs we work on every week, and the labs we work on in class. Homework is, you may not finish the labs in class, but we'll at least get started in class. The homework is just assigned at different times. Like if we look at week 1 here, we can kind of take a look and see what's here for week 1. So for instance, lab 1 is covered this week, and it's due January 28th. That means Sunday. But I think we're just going to do, oh yeah, part 1 and 2 only. We'll be turning that in, and then part 3 and 4 we'll work on next week. The labs are pretty much due every Sunday after the week in which we introduce them. So if we don't finish it in class, then you should continue working on it and turn it in by Sunday. The homework you have more time to work on, and oops, there's some notes there. Show. And this one's not due until February 18th. And these notes are actually for me, so let me, they're not supposed to be exposed. Sometimes I have notes to kind of guide me during the lab, and sometimes I have suggestions for how I will improve it next time. I don't know why they got all activated. The assessments are what? Kind of like the labs. You should finish them each week, but if you don't finish them each week, you still have time until the assessments I kind of round up right in front before every test. So yeah, and I haven't set up the assessments yet. I'll talk about those on Wednesday. So that covers the mechanics. People might be let's see. Yeah, roll call here, and then I can get out answers. Rock Monaghan, Vaughn, Daniel, Adam, Brian Bear, Nicholas Turner, Robert Davis, Mark Duncan, Hector, I think that's, there you go. Jacob Fries, then there's a Jacob Gomez, and Bawa Rutai, Devin Hubert, Ibrahim, Sean is here, Conrad is here, Conrad is here, by the way. We have a couple of great, we're going to have some great help this semester. Conrad has, right, can I share that you've introduced, you've offered to help people? So Conrad is a working professional software developer right now. What company do you work for again? TFT Group? TFD Group, which does, what do they do again? Analytical software for military contracts. So, and how many years have you been working there? 3 years. So, yeah. So he actually, Conrad's kind of one of these whizzes that kind of learned a lot on his own, and then he took 10A like way back 5-6 years ago. When? When he was 15. And anyway, you know, people like Conrad are just so talented they can just get hired without a computer science degree. Anyway, so he's got a lot of experience under his belt, but he's decided to go back to school to get his degree. And so he's taking this class to just kind of fulfill out, you know, his college transcript before transferring. And anyway, he's offered to kind of walk around and help people during labs, so he can be basically a TA as well if you run into problems. It's a big class, so it can be a little challenging for me to keep up on it with everybody. But I also strongly, and we'll be playing around with today, having everybody working with a partner, because when you're working all independently, that it's twice as many bugs we have to fix. Whereas if you're working with a partner, the two people can kind of catch the errors better. And you get through the material a lot faster that way. And you have a dialogue in which you kind of exchange information and learn a lot better that way as well. So we'll see how that works today. Then we also have a returning student, Ben Holland, who is he's now at CSUMB, and also a real whiz kid kind of guy. And he also went off and worked without getting his computer science degree, and now he's back at CSUMB getting his degree kind of finished up. But they have a service learning requirement, and so he's going to come and kind of volunteer some hours on Wednesdays. And just to show a hand, so he's actually, what he thought he would do is show up at like 2 on Wednesdays, so he can meet with people from 2 to 3 before class starts. Show of hands of people who might be interested in kind of coming in early and kind of having a working group kind of experience working with Ben. Yeah, so half a dozen or so. Yeah, he's really, really talented as well, and he's happy to help. And then he thought he would kind of hang out in class while I do the lecture, and then we go into the lab, so he can kind of help people in the lab on Wednesdays as well. But he'll just only be here on Wednesdays. So between Conrad and Ben, we should have a really good support, unlike we normally have. It's just usually just me. Yeah, anyway, that was Conrad. Thank you. Kelvin. Thanks. Shelby. Here. Irvin. Thank you. Cameron, that's all. Rocky. Coin win. I said that right? Q-U-Y-N-H. First after. Let's see. Pejaskumar. How do I say that? Pejaskumar. Okay. Marco. Nabil. Oh, see him. Salihula. Did I say that right? Yeah. Okay. Nicholas. Mateo. Eric. Krishna. Han. Good. I think that's it. Now, so who would like an ad code? How many people want ad codes? 1, 2, 3, 2, 3, 4, 5. Okay. So do you want to just shout out your name and I'll give you a number, or do you want to come up here? Vincent, last name? Okay, 279. Here. Okay. 0461. Next. Yeah. Okay. Happy to have it. What was your last name again? Alvarez. Been a while. 2734. Johan? LDA and then Johan. And 0343. Is there anybody else? Yeah. Kyle. Last name? 6617. Okay, anything else? Anybody else? Everyone got an echo? Good. Okay. Then, so if y'all got logged in and if you're in the Canvas site, one thing you might want to check out, just to make sure you get all the notifications. So when I post an announcement, it shows up here on the announcements section. And whoops, I forgot to delete all the previous announcements. I should get rid of those things. I'll do that later. But the announcements will show up here, and Canvas automatically sends them to your mpc.edu email. If you're not in the habit of checking your mpc.edu email, then you might miss these announcements that I make. As you can see, I'll be making quite a few announcements throughout the semester. And so one way you can make sure that you are informed is if you go to the beginning section here, you can click on this thing that says receiving notifications via text message or an additional email. And this will give you some advice on how to set that up in Canvas so that you can add an additional email address. So that way you'll get informed about all the announcements that I make without fail. So you should do that if you can. That'd be great. And then let me see if I can show you the final project. It's kind of cool when you look at the final project to see what you actually get to work on. This is the final project handout, and so the final project, I have a bunch of prepared projects which give you a lot of support in terms of there's a lot of design already done, so you don't have to actually create something from scratch. It's pretty hard usually to get going with a complicated idea from scratch. So these are a section of a collection of some of the things that you can actually do, which are some of them are quite fascinating, and it just kind of shows you the kind of understanding that you'll get from this class. One of them is called Evil Hangman, which is it's a deceptively evil game. But when you play Hangman, the person who plays Hangman, the computer is supposed to, like, say, come up with a fixed word, and then the player keeps guessing letters until they get the right word, right? Well, what if that word isn't actually fixed? What if instead of a fixed word, the computer is maintaining a list of possible words, and every time a letter is guessed, it looks at the category of words that have that letter in it versus the category of words that don't have that letter in it. And whichever category is larger, it goes with that. you can imagine, since the word is actually not chosen ever, it could be really hard to win that game. It's almost impossible to win in a finite number of guesses. And the challenges of how do you maintain these lists of all these different categories of words, and not only like words that have the letter versus don't have the letter, but like words that have the letter in the first position, maybe words that have the letter in the third position. How do you maintain all those words properly? It's a challenge, right? It's a challenge of organizing words. You start with a dictionary of maybe 120,000 words, and then you have to figure out how to narrow that down and manage it properly so that you always go with the correct, the most maddening choice. Well, that's one example. Another really cool thing you can do is genetic algorithms. These are actually algorithms that use evolutionary principles like natural selection to choose an optimal solution when there's many, many, many possible solutions available. So a typical difficult problem that you can use genetic algorithms on is the traveling salesman problem. This is a problem where a salesman maybe has to visit so many cities on their route to check with customers and sell their products. And the question is, you've got so many cities to visit, what's the best orders to go so that you travel the shortest total distance to visit all those cities, right? That's the traveling salesman problem. Now we're going to talk about orders of growth in this class, which is how quickly things blow up. The traveling salesman problem is a challenge because the mathematics of that means that the number of possible permutations of n cities, does anybody know mathematically what it is? If you have n cities, it's n factorial, which grows really, really rapidly. So if you have 10 cities, 3 cities is just 3 times 2 times 1 possible ways of visiting them, right? But then if you add a 4th city, you're multiplying that times 4, a 5th city times 5. It gets bigger and bigger, it grows faster and faster. So it becomes impossible to check all the possible ways of doing it. It would just take forever for the computer to go through every possible choice. Well, one thing you can actually do is come up with a population of possible solutions. And in this case, if you have, say, well, how many cities are there? Let's go like 20 cities in this example. If you have 20 cities, you can come up with a vector of a random shuffling of the numbers 0 through 19. And that becomes a solution. Well, you come up with a population of random solutions, and then you just evaluate them. How long would it take if I went this way with this solution, or with this solution, or this solution? And you choose the ones that are the best fit, so they have the shortest of that population, and then you can actually cross-breed the best solutions to come up with a bunch of new solutions that are going to be incrementally better. And over several generations, like maybe about 30 generations or so, you end up getting a really good solution. This is a test case where all 20 of the cities are arranged by happenstance along the perimeter of a square. Now, the computer doesn't know that they're arranged along the perimeter of a square, but that makes it easy because we know the correct answer when they're arranged on a square is just to follow the edges of the square, right? And the initial solutions might just randomly go from one point to another like this, and you can see how much longer that is. But then over 30 generations or so, you'll eventually iterate to where you have the optimal solution, and it's clearly an optimal solution. I actually had a student a couple of years ago whose brother was a salesman, and he wrote he solved this problem kind of so his brother could actually could sort of use it. But I don't know if he actually used it, but he had a fun time creating it. So that's the traveling salesman problem. Again, managing the data, how you actually efficiently come up with the algorithm for that is very interesting. This is a fantastic or fascinating, if you like physics, computational physics. Can I play this? The physics of Brownian motion is that like macroscopic particles like the blue dot in a liquid or a gas are being buffeted by these smaller particles like maybe atoms. And the macro behavior of this blue dot is influenced by the statistical impingement of the of those atoms. Now, what's interesting is in one of his, this is a physics geek problem, in one of his miraculous years, Einstein formulated a theory of Brownian motion. And his theory provided experimentalists with a method to count molecules with a microscope, and they could actually see if his theory was actually correct. And so you can kind of retrace his steps. What you do in this one is you have a series of images of multiple data sets of multiple images, and they show basically these particles like a video, right? One image after the other, where these dots will actually move slightly from one image to the next. And I still don't understand the physics of it, but by doing an algorithm on this, you can experimentally develop Avogadro's number, I think it is, in the process of doing this. So it's a really interesting image processing problem that you can sink your teeth on. And I had one student that I know that did this. She was actually taking this class online. She was from a community college in Southern California, Moorpark. And she had gotten an internship at Princeton, which is where the author of this problem is. And it was in computational nanobiology, which is pretty wild. It was she was a really, really talented student. And she's now actually at MIT. But they were doing an internship at Princeton, and then the following year they went to the Czech Republic to kind of do a follow-on project. So she had some fun going over there. But she did this on her own, and then when she arrived at Princeton, she found that the whole class that she was with from Princeton had also done this. Of course, they were Princeton students. So if you think you're going to be heading to Princeton at some point, you might want to do this one. It's a pretty interesting problem. There's also a really cool one is the guitar heroine, which is a synthesizer. You actually get to make a program that actually generates audio from a synthetic, it models a guitar plucking, a guitar string pluck. And there is somewhere on here, there is a demonstration of Stairway to Heaven, but I don't see it. Does anyone see it? Should be a link here. Well, anyway, it plays the Stairway to Heaven, and it's actually really good. I think probably I'm talking enough, so we should probably get to coding. But these are just a few examples of the kinds of stuff you can actually do. And this is just the tip of the iceberg. Actually, one other thing, well, it's hard to resist. There's another really cool thing, like if you're interested in like, what happened to hexaphone? That's weird. Well, that's in there somewhere. But if you like chess games, you know how some games, you have to keep track of all the different possible moves at every level, and the chess games, you know, now they're so powerful now, like the IBM chess game playing thing, the Big Deep Blue or whatever it is. Yeah. Whichever one you're comfortable. I'm gonna basically be demonstrating in BlueJ myself for much of the class, just because it's pretty simple. It gets you straight to the code. But some people like, well, there's I think there's Eclipse installed on these machines, and we'll probably fire that up at some point. Another one somebody just told me about, my friend student Ben, is IntelliJ, which supposedly is a pretty good IDE. You can kind of play around with either one of those. Yeah, but I mean, I won't. I mean, what you turn in, I don't really look at your IDE. I just look at your code. So yeah, it doesn't really matter what you use. It's whatever you're comfortable with. Yeah. Anyway, I've been talking too long. So let's go back and start doing some coding activities. Going down to the Lab 1 link. You can click on the week 1 Lab 1. And basically, the purpose of today is to get comfortable reviewing Java. Now, I don't want to lecture on Java review, but you can pull this up and we can maybe scan it real fast. And you can be looking at the language overview here, the examples that they have. And you can kind of look at Java, how Java program structure is. This is all really review. Java has different types of variables, primitive variables and reference variables. Primitive variables for holding basic bits of information, and reference variables for holding more complicated collections of information called objects. And there's instructions on creating expressions. Remember the division operator. When you divide two integers, you end up with an integer result in Java, right? These are some of the things you have to remember. Remember the remainder operator, modulus, 14 modulus 3 is the remainder of 14 divided by 3. That can be useful for certain things. All kinds of things you can do with strings, concatenation. You remember data conversions, which is how you convert from one type to another. If you want two integers to divide as floats, you can put the word float in front of the first integer, and then those will be done using floating point. This is a fun joke here, but I'll let you read that at your leisure. Object variables are called reference variables, and these are called, why are they called object reference variables? Anybody remember why they're called reference variables? What's different about object variables from primitives? Yeah, the variable doesn't hold the data, it holds a reference to where that information is actually stored in memory. So that's why they're called reference variables, and you'll see diagrams that kind of refer to that. So here's an example of this variable greeting. It doesn't hold the actual greeting, but it holds a reference to where that string is stored in memory. So all these things are kind of the nuts and bolts of Java that you should have learned in 10A, but you might need a little bit of review. Remember if statements, while loops, the control statements. You might want to kind of study these if you're trying to write something and you forgot how to do it. Logical operators, remember those? Not, and, or. Some examples. There's something called the switch statement, which we might not have covered in 10A, I'm not sure. The switch statement is a multi-way branch. You switch on some expression, and basically, depending on what the value is, you can do different statements. It's a bit quicker when you have a lot of different options to do than to have a bunch of if statements cascading, but you don't really have to use a switch statement. Often you can use a bunch of if statements. There's loops, there's probably methods in here somewhere. Classes anyway, how you write classes. We're going to cover writing a class later. This week we're really just focusing on, well, arrays. We'll be using arrays, so that's important. So remember, arrays are collections of data, and we'll be using arrays today to kind of store a bunch of information from a grocery cart kind of situation. And that is the lecture. Then just to kind of show you, here's the reading. You can, there's some, also some slides here on Java review you can look at. Let me see what's interesting on this one. This is actually pretty good. This is the whole appendix from the third edition. It's a 54-page review of the whole Java language. It's a very systematic thing. So if you want to look up something, unfortunately you can't search it because it's just a scan. But you can kind of find a lot of good stuff in here about how the language is set up and everything. So if you want to read it or whatever, that's an option for you as well. The assessment drills I will go over on Wednesday, so we'll save those for later. And we're doing Lab 1 Part 1 on Monday and Lab 1 Part 2 on Wednesday. And we're going to follow the instructions at this link, which I also am going to hand out to you. Before we pass it out. And the first one are a collection of coding bat drills. And whether you actually like to work in coding bat or not, you can work in the download, or you can work in coding bat itself. Actually, don't even bother. I'm not going to check on coding bat what you did. It's kind of tedious for me to go and look at those things. But this is kind of some preview practice. Working in coding bat is just a great way to get going. And we're going to be working with some warm-up exercises and working with strings, arrays, and logic. This is a way of getting some review done. And then on Wednesday, we should start tackling Part 2. The download is right here. So we'll start with the starting zip file. So grab this download link, and you can show that in the folder. Lab 1, you can open that. You can't really work inside the zip though. Be aware when you're working with zip files, when you click on a zip file, it has this pink header which says you're inside a compressed folder. You're using these compressed folder tools. A compressed folder is where you take the contents of a folder and stick it in a single compressed file, and it saves. It's easy. It makes it easy to download stuff. But in order to work here, we want to copy that inner folder inside the zip and paste that somewhere else, like on your desktop or in a folder that you want to work in. There's only one download for the lab. So you might want to make a CSIS10B folder on your desktop and paste the lab one in there. And I'll do this again in case anybody wasn't caught somebody off guard. But if everything worked okay, you'll open up the lab 1 folder, and then you'll click on the package.bluej file. And it says these are optional, but I'd like you to do them today. And if you don't want to do these drills, the coding bat option is where you could just go and work in coding bat. And maybe you'd prefer working in coding bat. These are drills from a previous, these are actually from, I think they're from 10A. So these are just kind of some review activities I kind of grabbed from 10A. But I think it's important to kind of start with some basics. And then there's some practice writing loops. But some of these drills may be a little tedious. So another option is to go straight to coding bat. CodingBat is a fun, interactive environment. You think you've all probably played around with CodingBat. And what I recommend is, again, we're just doing some practice problems. So alternate solving problems on each person's computer. Start a few of the warm-up exercises. Then work on solving 2 of the first column problems in each section: string 1, array 1, and logic 1. So that'll be 2, 4, 6. And then we'll look at some of the warm-up exercises. So I'm not going to collect these, but I want you to practice now just to kind of get your Java chops back. It's all good practice for people to just sort of play around with these things. If you really don't want to do this, you could tackle something else. But we're here to kind of learn. So if you find these easy, there's actually more challenging ones. There's often some really hard ones in here. So you can work at whatever level you want. And what I'd like you to do is work with a partner so that it's not everybody working in their own head, because you might kind of think that you'll learn more that way, but actually you learn a lot more when you're working with a partner. So what you could do is, the way it kind of works is when 2 people work together, one person is doing the typing and the other person is actually helping navigate and looking at and helping with the solution, and kind of having a dialogue as you go. So if you took the focus today, you start working on this computer, you guys work on Sean's computer, kind of go like that. Really great. It's more what is it's just So basically, you can either do these drills or do some CodingBat activities. There's a CodingBat file here that just pastes your solutions from CodingBat in there if you want. So let's I'll start showing you how the drills work, just so you get the idea of that, in case you haven't done this before. So the drills are set up with a scanner. Remember scanners? so that you can read from the keyboard. And there's a variable like int score. And we're just entering a test score, so we read that from the keyboard. Remember that keyboard.nextInt? That's how you read an integer from the keyboard, some of the basics of input. And exercise A is write a simple if statement that says pass if score is greater than or equal to 65. Otherwise, it says nothing. So to activate example A, or exercise A, you have to put a slash in front of the comment here. This is a block comment. When it starts /*, it's a block comment that goes all the way up to here. But if you put a slash in front of it, it activates the code, and now you can put an if statement here. You can say if, and you can say score. If it's greater than or equal to 65, you say greater than or equal to 65. And then you can put in curly braces if you want. And you can say cout, what? Typing C++. System out print line. And then you can say pass. Okay, and then you compile this. And when it compiles, you can then right-click and say void main, and say OK. And it'll ask you to enter a test score. If you type in 85 and hit enter, it'll say pass. So that's BlueJ, and that's exercise A. And if you finish that, you can go ahead and do exercise B. Now you can leave that open if you want, or if you finish exercise A, you can just put a slash here, and then remove, and then add a slash in front of exercise B. And now you're going to do an if-else statement. So these are really basic, but they do let you practice the syntax and then you can write a program that enters an age and you indicate whether they're a teenager or not. And then a problem where you write a method called paycheck to calculate a paycheck. So if that seems ridiculously easy for you, you can go to CodingBat, and that's another way to work. You can work on some warm-up exercises. And here's a function where it's giving an int, return true if it is within 10 of 100 or 200. And you can use various functions to do that. Some of these actually have solutions shown, so you can kind of show the solution if you want to. But most of them, after the warm-up, don't have that. It's really just a chance to kind of play around with getting your programming skills going, and I'll just walk around if anybody has any